Dear friends, welcome to Infos. Welcome to Oil and Gas Training Series by Infos. I hope you have watched all of my previous videos. If you didn't watch that one, there is a bottom side, there is a link is there. So you have to subscribe and keep the alarm button on. So you will get a notification of new videos released by Infos. So welcome to these videos. So basic instrumentation and control system part 9. We have already completed around 9 parts of previous videos, and I have posted or uploaded here in our Infos YouTube channel. Hope you have watched all these videos regularly. So in these 9 videos I have taken, this is the 24th video of oil and gas training session and 9th video from basic instrumentation and control system. In previous all videos we have discussed various parts of control system. In this video we are discussing about process safeguard system. In this video you can see that one is a operational system. Operational system is our control systems basic process control like a control loop we have discussed in previous videos. From this one we are discussing about safeguards. In this particular video process safeguard system we are concentrating on procedural safeguards and alarm and trip system. That is we are discussing. So note on this point safe limit value. So this is the operational set point. We have designed the parameters on the set point to operate a level, pressure, temperature, flow, etc. So in case any abnormality is coming up from the design operational condition, so the procedural safeguards and alarms, how it is working and trip system is working to protect and keep the operational personnel, plant, asset and environment to be safe and effective operation within the operation range, or to avoid any hazards in the operation field. So that we are going to discuss how the process safeguard is working. So welcome to this video. So process safeguard system. The prime goal of the plant protective equipment is the safety of the plant operators. That is very important, and plant process and equipment and its system. So a safe condition is a state in which no untraceable hazard is presented to operators, plant, equipment and process. That is a safe condition. So it is within the designed operating condition, within the set point of the parameters, within the set point of the process variable. So a fail-safe condition is one which a system remains in a safe condition on a failure of electrical power, instrument air or other similar source of energy. So any main source of energy like electrical power, instrument air or any process variable upset, process variable deviate from the set point. We have already discussed this one in the previous sessions, so previous videos, and so fail-safe condition can come to make hazards condition or abnormality in the process system. So our aim is to maintain the process within the safe condition. So that is so alarms are provided to warn of unsafe conditions and of impending difficulties which may affect the plant operation. Alarms are provided to warn. That is important word to remember. Unsafe condition, warn of unsafe condition. Trips are provided for safety reasons and to convert a hazardous plant condition to a manageable condition. So alarms and trips are different. So alarms taking one type of action. It is not actually is not taking action. It is only warn, or it is inform the operators, inform the panel operators about the condition is deviating from the designed set point. Within the operating limit, it is very deviating, or it is moving ahead or away. So operators and plant operating personnel has to take proper actions to maintain the process variable or plant condition to be safe. So trips are provided for safety reasons and to convert a hazards plant condition to a manageable condition. So trips are actually taking automatically taking some actions in case of alarms, operating variable, or set points, or any plant process conditions varying again above alarm or below alarm or deviating away from the alarms condition, then trip condition will activate automatically and take some effective measures to bring down the hazardous condition to a manageable condition. So these both are related to our previous instrumentation system, because this in physically how a alarm is coming and how a alarm can generate. So some instrumentation systems are there that we will discuss, and trips also some instrumentation systems are there. So it's a logic is there plus a physical instrument is there to activate this alarms and trip, and in general trip system. So trip systems are installed for safety reasons and will automatically act to control a possible hazardous condition. So alarms and trip operation. Many items of process pipe work and equipments are protected from operating at unsafe conditions by the installation of various switches, alarms, and shutdowns. So all protected from operating at unsafe condition by the installation of various switches, that is instrumentation switch, alarms, and shutdown logic. The process operator must be warned of such condition and excessively high or low level temperatures, pressure, and flow. This is achieved by the installation of instruments to show and announce faulty condition. So some examples are giving here in the plant. This is the, I told you in earlier sessions, abbreviations are using in P and ID, piping and instrumentation diagram. So in that one we can see this type of abbreviations and notations. So LSL, it is a level switch low, pressure PSL, pressure switch low, TSH, temperature switch high. This type of thing you can see in the P and ID. This is for notations for abbreviation for alarms, and trip the abbreviation is level switch LSHL, or level switch high and low, both way, or sometime it can write level switch high LSHH, level switch high, or FSHL, or FSHH, or PSHL, like flow switch high and low, or pressure switch high and low. Both way it can you can use or intimate in a explain in a P and ID. Let us see what is LSL, what is PSL, what is LSHH or LSHL or LSLL, like what is it actually, how it is working. By using a proper explanation, let us see how it is working. In the majority of oil and gas process and production plant, the control switch logic is as follows. Control switch logic means like alarm switch and trip switch. That is the thing, how the logic is working. For each potentially hazard condition, there is a pre-alarm. This is activated by a switch and gives the process operator visual and audible warning of the condition. The condition, the audio warning condition by sound, like a P sound, and a visual is a red light or yellow light blinking or continuously own position. So in control room or local panel room, local control room, or in the central control room, operators, various operating personnel can see and take immediate action and identify which hazard condition, which process variable condition, which area, which location it is activated, and where it is hazard condition, how he can read and understand immediately, and he can go and take an suitable step, uh, suitable operating procedure to maintain this to bring back to the normal, or he can investigate further to what happened exactly. For example, the level in a separator is monitored and controlled by a level control loop. We have already studied about the level control loop. LT is there, level transmitter is there, level LCV, level LIC is there, level indicator controller is there in the control loop, and LY is there, level transducer is there to changing the current signal to pneumatic signal, and finally final control element is there, LCV, level controlled valve is there. So this control loop we studied. So for example, the level in a separator is monitored and controlled by a level control loop. If the level moves exceeds a certain predetermined that is set point towards a high or low condition, then that is from level can go high or below the set point. Then the LAH, level alarm high, or LAL, level alarm high or low, both is activated via that is that alarms activated via a physical switch, level switch high or level switch low, installed in the field or in the separator itself. So we can see that one how it is working. So this will result in a visual and audible warning by an annunciator or the panel. Also a red flashing light indicating level high or low on the alarm panel. This action takes place in the control room. If the process condition is not corrected, that means by the alarm itself is process operators or suitable operating person can go and take an action. He can bring back to the process variable to normal condition, but still condition is not corrected, or again it is deviating from the set point or alarm point again and again, up or down. So this high and low alarms, also high visual audio warnings and high can activated. Relevant alarm can come high or low condition. So the process condition is not improving, it is getting worse, more and more worse condition. So relevant high or low, high and low will switch will activated. That is what is called a trip condition. So again the high and low alarms also, new alarms will annunciate, audible alarms or visual and audible alarms it will introduce and it will again start, and high visual and audible warnings. So when the alarm time, the alarms are slow, P like that one. So maybe in the trip condition alarm P like that one. So however the output of the switch is transmitted to here, the difference is the output of switch. This output of the switch is transmitted not only to the alarm or annunciator panel, and it also transmitted to a safety shutdown system, as well as its alarm shuts the plant or process down. So in the trip condition, it will take it will provide audible and visual alarms, and but it will take an important step to take an action to bring back the system normal. Let us see in a practical example how it is working. So let us see this basic separator. So inlet is coming from here, inlet is coming, basic inlet is coming, crude oil mixture is coming, you can see, or gas mixture is coming, whatever it is. So gas liquid separation is there, gas is out and liquid is out, and in the liquid line there is a valve is there, and the level is controlling by a level controlled loop. What are the item is there? The basic instrumentation, level indicator or level sensor or level transmitter is there in the. So the level is taking and converting into basic electric signal, We have already discussed this all in detail in our previous session. Please go through and watch it if you didn't see this one earlier. So you will get a good idea to understand the very good information on that one. So then easy to familiarize or coming to get through this knowledge easily. So this LT is level transmitter is there, and this is coming to control room representation. So LIC is there in the control room, either in the local panel or in the central control room. So LIC is there, a level indicator controller. So that output is here. The set point is there. Set point is there. So that output is coming to back to the controller control valve, that is LCV. So this is the basic level control loop controlling by our process separator. So in this one, let us see how this alarms and trip system working. Let us see how this is working. So I have made an example here. Example, set point is here 50%. So 50% level of oil. Oil is the our set point. So separator should always work. That is the design, our plan design. Separator should always work a level of 50 percentage of the level inside. So in case sudden flow increase and the level increase to 51, 52, 53, in that case the level indicator reading is going high, level transmitter reading is corresponding reading is providing to controller. Controller set point is 50, so 53 minus 50. So here the positive and here negative value, or slight positive deviation is there. That deviation will going back to control valve, and the controller giving command to control valve to inform or giving advice to open a little more and bring back the level back to 50%. That is the normal operating condition. It is in auto mode. This is the A is mean auto mode. So that in auto mode controller will take care. Always it will try to maintain our set point value 50%. Even the sudden flow is reduced due to some other reason. In case that one it is coming to flow is now in 48%. That also it will correct according to the same logic, and valve finally will close little to maintain the level up to 50%. This is the usual control loop logic. But in case any abnormality is coming, sudden upset on the process inlet, the level can go very high or very low. No, not very high, it is deviating away from the set point value. Say look at here, and say if suppose it is level is 60%, it's going up, or LSL level is going to 40%, so that is 10% down from the set point. So in that case level alarm high we can design, we can fix, and a level switch off when the level is getting 61%, above 60, or just to reach 60, we can command level switch low, level switch high can activate, and level alarm high or visual and audible alarm activate in the this area control room. How it is working? Let us see. See, I have added two switch. One switch is here, level switch high. Level switch high. It is activated at what time? It is activated at what time? 60% of level. So this level is 50% set point, but now the level is 60%. Immediately the level alarm high is activated. I have removed this one. This is normal operating condition. Look at the picture. There is two changes coming into the presentation. See that one. One is level switch high activated at 60%. Immediately level alarm activated. Level alarm high activated in control room. So operator can go and take the decision immediately, as we discussed in earlier this one. The same way here is going to activate a level switch low at 40%. Look at that one. The physical instrument is there. Instrument switch is there to watch that when the level is coming around 40%. So that is here it is there, and look at that one, level alarm. The level is activated 40 percentage, so the immediately level alarm low activated in the control room. This is the connection is there. So these are the two condition for the level. We can put various other examples are also in this one, but in the simple example, I hope you will understand perfectly. So then what about a trip condition? Trip condition, if the level again deviate away from the alarm point, higher or lower. What is higher? If the level is not maintaining, control valve is fully open now, or control valve is fully closed, fully but still level is increasing due to various reasons. Forget about the reasons now. So again it is level activated, level is increasing up to 70 percentage. 70 percentage. So what will happen if the level is increasing such a way? If the level is increasing, what will happen? The liquid hydrocarbon can carry over with the gas hydrocarbon, gas phase. So in that case, a liquid can carry over maybe the gas outlet lane. So the gas is going to compressor. So it will create much problems in the compressor or any other downstream equipment in the gas line. So we have to avoid that one, and we are wasting the liquid in the gas line. So we have to avoid that one. Sometimes this gas is going to flare, so that liquid will go into flare. The whole burner will damage, and combustion will not be completed. So that is the another problem can create. So in that one we have to maintain the level up to 50 percentage. So we have tried the alarm, and operator is trying to take action, but still system is not getting back and getting normal or manageable position. Level is going high and high. So that is a 70 percentage high. Now what will happen in the picture? So here it is a level switch high is this is a physical switch connected into the separator. So separator pressure when it is touching to level switch high level switch high is creating level alarm high. Immediately it will create annunciate and alarm plus action on the inlet or in the outlet of gas, or inlet of the oil line, or outlet of the gas line, or this liquid outlet line. Three action or one action or two action according to the logic it will take immediately. This is the higher condition, level switch high. So another example is a level switch low. Level switch low is up to, I have given example of 35 percentage level. It will vary according to the situation of the each operating condition. So what will happen in that this one level switch low. See, when the level switch low is a physical switch activated, immediately level alarm low is activated. So that also taking action on the inlet shutdown valve, or gas outlet BDV blowdown valve, or shutdown valve itself, and this LCV or subsequent downstream shutdown valve. Any action will take place. So it is clear. I hope you will get a clear understanding on what is alarms and set point. So same way in the P&ID, in the process we can give pressure alarms, pressure alarm high, low and high through PSL switches, pressure switch low and pressure switch high, and trips pressure alarm low and pressure switch through pressure switch low and pressure alarm high through pressure switch high. Same like temperature also alarms and trip switches. Same like flow alarms and trip system providing in operation field. If you have any chance to get to visit the field in your operating plant, just to go to the near equipment and find out, or read the P&ID properly to find out this type of notation, and go to the field and understand where is physically this pressure switch low and pressure switch high is located, how it is look like, and moreover temperature switch or level switch, this type of switches, and what is the set point of these switches. in what percentage or what unit it is activated in, and once it is activated, where the audible and visual alarms are coming. This type of thing you have to go through the your system, your plant, and your P&ID, understand. So you will get much familiar with this type of process safeguard system. So thanks for watching this video for process safeguard. Of course, we are planning to bring back more process safeguard system one by one now to our through our Infos channel. I hope you are understanding and going through this various video sessions regularly. Please subscribe this channel for timely updation and information. So also please join in and our Telegram channel Infos for various other updates happening in and around the oil and gas area. We are also starting to update various job vacancies in various fields. So once it is useful to our students, it will be good for us. So thanks for watching. Of course, we are coming with a new video soon. Goodbye.